Today's this video we will study about the designing of silt excluder. Okay, we have a given question here, and this question is taken from the world question. This question is already asked in Pokhara University in 2018 fall. Okay, so we taken this question, okay, from the world past question related to the designing of silt excluder. Okay, so we're gonna solve this numerical in this video. So if you are new to the channel, please like the video, do subscribe the channel, okay, and press the bell icon so you will get regular update. Okay, so we have given question over here, and we have to design silt excluder. Okay, so let's start the solution. So we have a given question here, design a silt excluder. We have to design silt excluder, as I told you, for the diversion headwork for the following given data. This given data are given over here, and we have to design silt excluder, okay, for the diversion headwork. And the given full supply discharge of a canal equal to 200 cubic, or you can say 200 meter cube per second, and the crest level of under sluice equal to given 200 meter. Crest level of head regulator equal to 202 meter. Bay width of under sluice is given over here 16 meter. Okay, and we have to design a silt excluder, okay, for the diversion headwork. Okay, so let's see the solution. And before solving this numerical, if you are new to the channel, please do like, share and subscribe the channel, okay, and press the bell icon so you will get regular update. Okay, and I have uploaded different video related to irrigation engineering as well our civil engineering, so you can simply visit to our channel. Okay, so let's see the solution. In very first step, we have to calculate the discharge of silt excluder. Okay, and the discharge of silt excluder is taken the 20% of total canal discharge. Okay, so this design discharge of silt excluder becomes 20% of canal design discharge. Okay, so 20% means simply we take on 0.2, and the canal design discharge is already given in the question, that is 200 cubics. Okay, this is full supply discharge of a canal. Okay, so we have to just take 20% of this discharge. Okay, so 0.2 into 200, then we get that design discharge of silt excluder equal to 40 meter cube per second. Okay, now we have to assume the value of velocity. Okay, the value of velocity, so let's assume velocity b equal to 2 meter. Okay, then we can calculate the area of this x section. Okay, a equal to q by v, and the value of q and b is already known, that is q equal to 40 and velocity equal to 2 meter. So after calculating this, we get the value of area equal to 20 meter square. Okay, now we have to assume the thickness of roof slab. As we studied in the theory part, the thickness of roof slab is taken generally 0.2 meter. Okay, so whenever we take the thickness of roof slab equal to 0.2 meter, then the height of tunnel, that is capital small h, equal to 202 minus 0.2 minus 200. Let's understand how this becomes. Okay, so now we have to calculate the height of tunnel. Okay, the height of tunnel h, we already studied. The height of tunnel h is taken, we have to minus the two different values, that is the thickness of roof slab and the crest level of under sluice. Okay, we have to minus these two values from the crest level of head regulator. Okay, so this can be also written in this form. Okay, the value of h, that is the height of tunnel, h equal to crest level of head regulator minus thickness of roof slab minus crest level of under sluice. Okay, so you can write the value of h, that is height of tunnel, in this way. Okay, so we have given this all value. Okay, crest level of HR, crest level of head regulator is also given in the question. Crest level of head regulator is given 202, so we just keep this value. Thickness of roof slab, we already known. Let's the thickness of roof slab is taken 0.2 meter. Okay, as I said, and the crest level of under sluice, this is also given in the question. The crest level of under sluice, you can see here. The crest level of under sluice is 200 meter. So we just keep these all value, and after calculating this value, we get the head of tunnel equal to 1.80 meter. Okay, so now we have to calculate the total clear width. Okay, and the total clear width, that is the value of B, is taken A by H. Okay, whenever we have the B and H, we can calculate the area equal to B into H. That's why we take the value of B equal to A by H with the help of this formula, area formula. Okay, and the value of A is already known, that is A equal to 20, and the value of H we already calculated again before, so this value is 1.80. So after calculating this value, we get the total clear width, that is the value of B equal to 11.11 meter. Okay, now we have to calculate the cleared span. Okay, cleared span and number of tunnel and thickness of divide wall. Okay, we have to calculate this value. Okay, for this we simply for cleared span of 2.1 meter. Okay, for cleared span of 2.1 meter, number of tunnel, we have to calculate number of tunnel. Okay, and we have total clear width equal to 11.11 by the clear span. Clear span is taken 2.1 meter generally. Okay, so I will write in this form: total clear width, total width by the clear span. Okay, we have to do this further determining the number of tunnel. Then number of tunnel equal to total width, and total width is we already calculated 11.11, and the clear span is taken 2.1 meter generally, and this value becomes 5.29, and generally we have to provide 6 number of tunnel. Okay, because number of tunnel is not in decimal. Okay, this is in in a fixed number, so number of tunnel becomes 6. Now we have to calculate the thickness of divide wall. Okay, and thickness of divide wall is generally taken 0.60 meter. Okay, and when we take the thickness of divide wall equal to 0.60 meter, then we can calculate the overall width. Okay, and for the 6 number of tunnel, we have to multiply with 6. Okay, and we have to multiply the 6 for the 6 times of clear span. Okay, so 6 into we have clear span is taken 2.1 meter plus 5 times of 0.6, and this 0.6 is taken for the thickness of divide wall. Okay, so we have to just calculate this value, then we get the value of overall width equal to 15.6 meter and nearly equal to 6 meter. Okay, 16 meter. So in this way we can calculate the different parameter for the silt excluder. Okay, and I request if you cannot understand these all parameter, you have to study first the theory part. Okay, and I have uploaded the theory part related to the designing of silt excluder. Okay, in that video you can see different these parameter, how we have to take the value of clear span, thickness of wall. Okay, and thickness of roof slab. Generally you can take this value. As I mentioned, thickness of roof slab is taken 0.2 meter, thickness of divide wall is taken 0.6 meter, and clear span is generally taken 2.1 meter. Okay, so after knowing this value, you can calculate you can design the silt excluder. Okay, so this is all about this numerical. Thank you very much. See you in next video, and please study about the theory part of designing of silt excluder before solving these numerical. Okay, that will be very beneficial for you, and I will keep the video link of silt excluder theory part in taken. This question is also asked in Pokhara University. Okay, so we are going to solve this numerical, and this numerical is designing of sedimented excluder. Okay, so let's see the solution. And if you are new to the channel, please do subscribe the channel, like the video, and press the bell icon so you will get regular updates. Okay, and I have uploaded different numericals related to our irrigation engineering as well our civil engineering. Okay, so you can visit our channel. Okay, and let's see the question first. Design a sediment excluder is to be designed for a canal head of taking from a river with a dominant discharge of 800 cubic. Okay, we have given discharge is 8000 cubic. The order data of a canal excluder, and these all data are given for designing of sediment excluder. Canal discharge is given 284 cubic, width of under sluice span of a barrage where canal regulator is to be provided with an excluder equal to 15.35 meter. River excluder is given 15.35 meter. River bed slope equal to 1 by 4000. Average sediment diameter 0.37 meter. Head available 0.8 meter, and the meaning rigidity coefficient is given 0.06. Okay, so these all parameters are given for designing of sediment excluder. Okay, now we have to design. So let's see the solution. As we already discussed in previous video, we have to take 20% of the canal design discharge. Okay, for the discharge of sediment excluder. Okay, so design discharge of a silt excluder is taken 20% of a canal discharge. Okay, it means 0.2 into we have to take the canal design discharge, and this is given in the question 284. Okay, so we have to just multiply 0.2 into 284. This means 20% of canal discharge. Okay, so after calculating we get design discharge for the silt excluder equal to 56.80 meter cube per second. Okay, now we have to design a tunnel. Okay, for the silt excluder we have to design a tunnel. In very first step we have to assume the number of tunnels that we are going to provide for the sediment excluder. Okay, so let us assume in this numerical we are going to provide a number of tunnel equal to 6. Okay, so let us provide 6 number of tunnel, and in second step we have to calculate the width of tunnel. Okay, width of tunnel at the exit. Okay, for the width of tunnel we have to assume the value of a divide wall. Okay, and the value of divide wall is generally taken 0.6 meter as we discussed in previous video also. Okay, you can see here we have taken okay, you can see here thickness of divide wall is generally taken 0.60 meter. Okay, so 0.6 meter width of divide wall. Then the width of tunnel at exit equal to 15.35 minus 5 into 0.6. Okay, and you can see this value is taken, and for the width of tunnel at exit we have to minus this width of divide wall. Okay, so for this we have to divide this divide wall, and as we already discussed, we are going to provide 6 number of tunnel. Okay, that's why we have to minus this width into this number of tunnels. Okay, so we have to minus this value, width of divide wall. We have to total calculate total width of divide wall. Okay, for the this total width of divide wall is taken 5 into 0.6. Why we multiply this? Because whenever we take 6 number of tunnels, okay, the total width of divide wall becomes 5 times of 0.6. Okay, so we have to minus this value from the river bed of slope. Okay, this is the river bed of slope, river bed slope minus 5 times of 0.6. Okay, so river bed of slope is given in the question. You can see here the river bed of sorry, this is the river excluder. Okay, river excluder. Okay, so the value of river excluder is given in the question 15.35. Okay, so we have to just minus this width of divide wall from the river excluder. So the river excluder is given 15.35 meter minus 5 times of width of divide wall. Okay, so this value becomes, and for the single one tunnel we have to also divide this value with number of tunnel, that is 6. After calculating this value we get 2.06 meter. Okay, that is the width of tunnel at exit. Okay, okay, now in third step we have to calculate discharge through one tunnel. Okay, so we have calculated total discharge for the silt excluder is 56.80, and now we have to calculate discharge for a single tunnel. Okay, and whenever we calculate a discharge for a single tunnel we have to divide the number of tunnel. Okay, that is a 6 for this value. Okay, we have total discharge is 56.8 and the total number of tunnel is 6. So we have to divide with the total number of tunnel for getting a discharge of single tunnel. Then the value of discharge becomes 9.47 meter cube per second for the single tunnel. Okay, now in fourth step, the height of tunnel is chosen such that velocity through it is in order to 2 meter or more. We have to take the height of tunnel, okay, according to the such that the velocity through it is in order to 2 meter or more than 2 meter. Okay, for this let us assume exit velocity is taken higher. Okay, that is the higher of 2 meter per second. Then we have to say, let us assume the exit velocity is 3 meter, or you can say you can take the value higher than 2 meter. Okay, 2.53 and whatever you want. Okay, so let us assume 3 meter per second. Now we have to calculate the area of tunnel at exit. Okay, and we have already the velocity is 3 meter and discharge is also you can see here 9.47 for a single tunnel. Okay, now we can calculate the exit sorry, we have to calculate the area of tunnel. Okay, for the area of tunnel we can simply use area equal to Q by V, as we know. Okay, and we will use this formula in so many times. So the discharge that we have calculated for a single tunnel is 9.47 and the velocity we taken is 3. Okay, then the area is becomes 3.16 meter square. Okay, and whenever the area becomes and the thickness is also known, that is 2.06 meter. Okay, width of tunnel is already known. Okay, and whenever the area and the width is known, you can see here area equal to width into height. Okay, with the help of this formula we can simply calculate value of h, and the value of h is calculated area by width. Okay, and area is already calculated, that is the 3.16, and we have to divide this value with width. Okay, and we already calculate the width of tunnel is at exit is 0.6. Okay, after calculating this value we get the value of height equal to 1.53 meter. Okay, that's why provide height of tunnel at exit equal to 1.53 meter, and this is provided throughout the tunnel length. Okay, so this is the height of tunnel at the exit, that is 1.53 meter. Okay, in now in 5th step, in 5th step we have to calculate the width of tunnel, okay, at infinity. For this, let us assume velocity at infinity equal to 2 meter. Then we can calculate the area equal to Q by V. Q is already calculated, that is discharge for a single tunnel is 9.47 by velocity is taken if 2 meter, then the area becomes 4.74 meter square. Okay, and tunnel width at infinity equal to 4.74 area by we have to as we calculated in this previous, okay, B area by we have to divide by 1.53. okay, that is the height. Okay, as we calculated h equal to 1.53. okay, then this value becomes 3.09 and this is nearly equal to 3.10 meter. Now we have to calculate for better smooth infinity width of tunnel equal to 2 times of exit width. So 2 into exit width we already calculated, that is 2.06 meter. Okay, you can see here we have calculated width of exit tunnel at exit equal to 2.06 meter. Okay, so this value becomes 4.12 meter. Okay, so we have calculated different parameter for the tunnel as well discharge for the silt excluder. Okay, in this way you can calculate the sediment excluder. Okay, hope you guys are understand well. Thank you very much. See you in next video. If you have any queries, please comment down below. Thank you very much, and don't forget to like, share and subscribe the channel. Thank you. And have to design silt excluder from the given this data. Okay, so let's see the solution. And before this, if you are new to the channel, please do like, share and subscribe the channel. Okay, and press the bell icon so you will get a regular update. Okay, and I have uploaded different video related to irrigation engineering and civil engineering, so you can visit our channel as well. Okay, so let's see the solution. Okay, so you can see here this is given question, and now we have to design silt excluder. Okay, so you can see design a silt excluder from the given data, and data are canal discharge is given 150 cubic, width of under sluice waterway 13 meter, average sediment diameter 0.37 meter, Manning's roughness coefficient, that is eta equal to 0.016, level difference between crest level of canal, head regulators, and the upstream under sluice floor equal to 1.3 meter, and the length of tunnel equal to 70 meter. Okay, so this is all about the given data, and now we have to design silt excluder. Okay, and whenever in the question asked to design silt excluder, then we have to design different parameter of the excluder. Okay, for this we have to design, basically I will show you here, and I have already discussed in previous video. We have to calculate these all parameter, that is entry width, exit width, height of tunnel, exit velocity. Okay, so these parameters that we have to calculate for the designing of whenever in the question asked to design a silt excluder. Okay, so in solution, very first step we have to calculate the capacity of canal. Okay, and the capacity of canal is always taken 20% of the total canal discharge. Okay, so we have to take 20% of total canal discharge, and it means 0.2 into canal discharge is already given in the question 150, so this value becomes 30 cubics. Okay, and the capacity of canal becomes 30 cubics. Now we have to assume entry velocity and exit velocity. So let us assume entry velocity equal to 2 meter per second and exit velocity equal to 3 meter per second. Okay, we have to always use the exit velocity greater than the entry velocity. Okay, this already discussed in the previous video. now we have to determine the entry cross section area. Okay, and whenever we have the discharge and velocity, we can simply calculate area, and area can be calculated with the help of this area equal to q by velocity, and the discharge is taken 30 and velocity is 2. Then the entry cross section area equal to 15 meter squared, and exit cross sectional area equal to 30 by, we have to use velocity. When we calculate entry cross section, then we have to take the entry velocity, that is 2, and when we calculate exit cross sectional area, we have to take the velocity, exit velocity. Okay, so we have to take these two velocity for these two different area. So the entry cross sections become 15 and exit cross section becomes 10 meter square. Okay, now we have to assume slab thickness. Slab thickness is generally taken 30 cm. Okay, or you can say 0.30 meter. Okay, and height of tunnel equal to 103 minus 0.3. This value we have to minus this value, slab of a thickness. Okay, and when we subtract this slab thickness from the upstream under sluice floor, that is given in the question 1.3 meter. Okay, after minus this value 1.3 minus 0.3, that is slab thickness, then we get height of tunnel, that is value of h equal to 1 meter. Okay, now we have to calculate the width of tunnel at the entry. Okay, and when we have the value of a and h is already known, then we can simply calculate width of tunnel b equal to a by h, and the value of a is already unknown, that is you can see here for the entry we have to take the value of a equal to 15 and the value of h is 1 meter. Okay, so this value becomes 15 meter. Okay, so this is for the entry. Okay, you can write also here. Now width of tunnel at the exit. Okay, now we have to calculate width of tunnel at exit as calculated in the entry. We have to just use this, but we have area is different. Okay, for the entry we have area equal to 15, so we just take 15, and for the exit we have the area calculated 10, so we have to just take 10. Okay, and h is taken 1, then this value becomes 10 meter. Okay, and let us provide number of tunnel n equal to 4. You can provide 4, 5 or 6 generally. Okay, so in this numerical let us provide number of tunnel equal to 4. Then width of each tunnel, total width of canal we have calculated, you can see here total width of tunnel equal to 15 meter. Okay, and whenever we provide number of tunnel equal to 4, then we have to calculate the width of a tunnel for the individual. Okay, so width of each tunnel equal to total width, that is 15 meter, and number of tunnel, that is 4. Okay, so width of each tunnel becomes 3.75 meter at the entry. Okay, or you can write here okay, at entry. Okay, so this is the width of each tunnel in entry equal to 3.75. Now we have to assume the width of divide wall. Okay, and I already told you in previous video. Okay, we have to always take the width of divide wall is 0.6 meter. In previous video we have also taken the width of divide wall equal to 0.6 meter. You can see here, assume width of divide wall is 0.6 meter, and also in first numerical we have taken the width of wall equal to 0.6 meter. You can see here. Okay, so in we have to take always the width of wall is 0.6 meter. Okay, divide wall, then the total width becomes 15 plus 3 times of this 0.6, because whenever we provide 4 number of tunnel, then we have to multiply the width of divide wall with 3. Okay, then we can only get total width. And in previous video I already told you, whenever we take the total number of tunnel 6, then we have done you can see in previous video we have taken 6 number of tunnel. Okay, that's why we have to multiply this width of divide wall width of 5. Okay, we have to multiply this width of the divide wall with the n minus 1 value. Okay, when we take n equal to 6, then we have to multiply with n minus 1, that is 5. Okay, and in this video we have taken the number of tunnel equal to 4. Okay, that's why we have to multiply with n minus 1, that is n minus 1 equal to 3. Okay, so you can see here n minus 1 is 3, total width equal to 15 plus 3 into 0.6. Okay, then it becomes 16.8, and at exit width of each tunnel equal to, we have to calculate for the single tunnel. Then we have total number of tunnel equal to 4, so we have to just divide this width of tunnel at exit 10 meter by 4. Okay, then the width of each tunnel becomes 2.5. Okay, so you can write these all value in you can see here width of tunnel is 2.5 meter. Okay, number of tunnel equal to 4. Okay, width of each tunnel equal to this. Okay, capacity of canal equal to this. So you can also like this. So this is all about the solution of this numerical. Okay, in this way we complete the numerical related to the design of Silt Excluder. Okay, and if you understand these numerical, you can design any numerical given in the question. Okay, with the help of these three numerical solution. I hope guys you understand very well. If you have any queries, please comment down below. Thank you very much.